Alright, so hello and welcome back to the continued coverage of the walkthrough series. And in this episode, we are going to be looking at the 9618 variant 4.2 of May, June 2022. And we'll be doing the Python implementation for question 1. So it says here that a program needs to use a stack data structure. The stack can store up to 10 integer elements. A 1D array called stack data is used to store the stack globally. The global variable stack pointer points to the next available space in the stack and is initialized to 0. So for part A, we're supposed to write program code to declare the array and pointer as global data structures. And we're also going to initialize the pointer to 0. So let's go ahead and look at that implementation here. So you see that I have the implementation going on between lines 4 and 5 there. So we can see the stack data list that's going to hold 10 elements on line 4. Then we have the stack pointer variable. Remember, these are global because they've been declared outside of any function. So it means that any other function that we are that's going to make use of these two variables, as it were, it's going to have to make use of the global keyword as it is later on. So you can go ahead and copy this code and paste it inside of the evidence document. Then moving on to part B, we are going to write a procedure that's going to output all the 10 elements in the stack and the value of the stack pointer. So let's go ahead and look at the implementation here. So we've chosen to go with the identifier name output stack, and we are simply going to print the stack data list as well as the stack pointer value, as it were. So of course we can go ahead and copy the code and paste it inside of the evidence document. Then it says here that the function push takes an integer parameter and returns false if the stack is full. If the stack is not full, it puts the parameter value on the stack, updates the relevant pointer, and returns true. So basically, you will just need to implement the functionality for a push operation on the stack data structure. So let's go ahead and look at the implementation that I have going on here. So here we have the function definition on line 13 there. I didn't use annotations, but of course you would actually go ahead and make use of annotations. Like for instance, since you know that it's going to return a boolean, you could actually annotate that it's going to return a boolean. And for this value variable, the parameter, you can actually annotate that this is going to be a string, like so, so that your code is more documented, as it were. And I think you can also do the same thing for this stack output stack function. Since it's a void function, you can just point out that it's going to return as it were, since it is a void function. So it's good practice to always use annotations for your Python solution, as it were. So you see that we are making reference to the global stack variable on pointer 14 there, on line 14 rather. And then we are checking to see if the stack is full, in which case if it is full, then it means we cannot push anything onto the stack. So we are returning false on line 16 there, after checking if the stack is full on line 15. Then on line 17, we are going to take the value that was passed as a parameter and store it inside of the stack pointer index position for the stack data list, as it were. Then of course we are updating the value for the stack pointer by 1 on line 18 there. Then we return true ultimately to show that we are able to push our value onto the stack, as it were. Maybe just to fix something real quick here, I think I did annotate it as a string, but it's actually supposed to be an integer, because remember our stack is actually taking integer variables, as it were. So of course you would go ahead and copy this code and paste it inside of the evidence document, as it were. Then moving on to the next aspect here, we are going to look at item 1. We are to add the main program to test the push function. The main program needs to allow the user to enter 11 numbers and attempt to add these to the stack. It also needs to output an appropriate message when a number is added to the stack. It's also going to output an appropriate message when a number is not added to the stack. If it is full, then it also needs to output the contents of the stack after attempting to add all 11 numbers onto the stack. So let's go ahead and look at that implementation here. So let me scroll all the way down to the main function here on lines 31 through 46. So what we need to do is we are going to make use of a for loop here, because we know that we need this loop to run 11 times, is it? We are supposed to enter 11 numbers here, so our loop is going to run 11 times right there on line 33. Then on line 34, we are prompting the user to enter a number, then we are typecasting it to an integer. So you can see that we are chaining methods. Here we are chaining the input function as well as the int function. Then we store the value inside of that num variable on line 34. Then on line 35, we are pushing the number onto the stack, as it were. But remember that push actually returns a boolean true or false. So if push is true, then we simply print that the number has been added to the stack. But otherwise, if push is false, then we can point out that the stack is full and that the number was not added. Then ultimately, we are now outputting the stack, as it were, on line 39 there. So let me see if we have satisfied all the conditions. Output an appropriate message, output the contents of the stack. Yeah, so we would have completed the implementation for this part, and of course you would go ahead and copy the code and paste it inside of the evidence document. Then moving on to item number 2 there, we are to test our program with the following test data that's provided here. Then after which we can take a screenshot and paste it in the evidence document. So let me just pull up the terminal real quick. Then I can scroll. I can rather pull this down a little bit so that you can see the test data, as it were. Then I need to make sure that I'm in the correct folder where my script is. So I'm going to cd real quick, June 22 v42. Then here I can just clear out the console so that I give myself space to work with. Then the name of my file, you can actually see here that it's Python, rather it's question1. So I'll just type the file name there, question1 j22_v42.py. Then I'm going to run that, and I'm getting an error because I didn't invoke the Python interpreter. So let me just cycle the question one more time, then type Python, then space, then this time around it should work. So we are supposed to type 11, then 12, then 13, 14, 15, 16, 17, 18, 19, 20, 21. So you see that there we have the output. So having done this, you can go ahead and copy the code, rather take a screenshot of the output and paste it inside of the evidence document, as it were. So let's see here if we still have any requirements that we need to satisfy. So for item 2 we are done. So this is the output, right? So you see that we were able to add the numbers 11 through 20, but 21 was not added to the list, as it were. So you can ignore this other part right here. This is for the later part of the question, as it were. So let me just pull this down. So E says that we have a function pop that returns -1 if the stack is empty. Then if the stack is not empty, it returns the element at the top of the stack and updates the relevant pointer. So we are to write program code for the function pop. So let's go ahead and look at the implementation here. The pop function is right there on line 22 all through line 29. So line 22, there we have the function definition. Then line 23, we are making reference to the global stack pointer variable that we declared earlier on. Then we are checking to see if the stack pointer is less than or equal to 0. If it is less than or equal to 0, then it means that there's nothing inside on the stack, as it were. So it means we cannot pop anything. And according to the requirements here, it says that if the stack is empty, we return -1. You can actually see the requirement right there. So that's what we are checking for on lines 24 and 25. Then on line 26, we are decrementing, basically we are decrementing the value for the stack pointer by -1. Then we are also taking the value that is currently being pointed at by the stack pointer inside of the stack data list and holding it inside of this value variable, as it were. Then we can also just clear the value, that is to replace it with a 0. That's what we are simply doing on line 28. But of course, this step is actually optional. So you could actually not have this. Wait, what did I do? Okay, let me just. This is what I wanted to do. So I just wanted to cut this line. So you can actually not have this line, and the code would still work just fine. Then of course ultimately you are returning the value that we just removed from the stack, as it were. So of course you could go ahead and copy this code and paste it inside of the evidence document, as it were. Then item number 2, after the code you wrote in the main program, there you are to remove 2 elements from the stack using pop, then output the updated contents of the stack. Then I'm just going to pull up my terminal because I had completed the question as it were before recording the video, so you can actually see that I have a complete solution here going on. So I'm just going to pull up here and show you. So you remember that we did input the test data that we were given earlier on, and there we have the current state of the stack as it were. Then after removing the 2 values, remember a stack is going to remove the most recent values as it were, so we removed 20 and 19 there, right here. Then ultimately our stack is actually going to still have 10 elements. Remember, I did update the values that I removed by replacing them with zeros as it were, so that's why you see I have these zeros going on. But otherwise you can actually see that this stack is actually the same thing, but this time around it only has these values of 19 and 20 removed from it, and the current value of stack point is actually 8 because it's currently pointing at number 18 there, element 18 rather. So yeah, I think that's just about it for this one. Let me see if we still have any other. No, we no longer have any other solutions that we need to implement. So this does it for question 1. I'll see you in the solution for question 2.